Scale out. Most LLM ops teams are fighting the wrong fire. A widely read engineering post argues that scale out is the silent killer. Every time traffic spikes and a new replica spins up, production effectively reruns the cold path. Container pull, massive weight download, warm-up compilation, and users time out before capacity arrives. For a 70B model, the breakdown is typical. 30 to 90 seconds to pull a 10 to 20 gigabyte container, 2 to 5 minutes to fetch 120 to 200 gigabytes of weights at 1 to 2 gigabits per second, another 1 to 3 minutes to allocate KV cache and compile kernels. Serialized, that's 5 to 10 minutes until healthy, so most teams either over-provision idle GPUs or risk failures during surges. Providers can hide this by pooling warm GPUs. Self-hosters can't escape the physics. Even with local NVMe and pre-pulled images, the best case, 60 to 120 seconds, collapses under truly cold, unexpected scale-outs. Kubernetes best practices, pre-caching container images, pre-pulling weights with a daemon set help, but loading into GPU, KV allocation, and warm-ups still make scale-out a mini cold start. Bare metal and faster fabrics shave edges, not fundamentals. The dilemma, idle cost versus SAID, missed SLOs, pushes teams to focus on demand shaping and forecasting. Those tactics improve averages, but they don't remove the bottleneck. You still rerun the slow path when you need fresh replicas fast. The gap between lab best case and real-world worst case is exactly where production pain lives. Some engineers report sub-2-minute scale-outs using tuned storage and attach and load workflows, but note that exotic storage and premium infra aren't always available or cost-justified. Compared to databases where state is relatively small and metadata-centric, LLMs lug hundreds of gigabytes of weights and GPU-specific startup costs. Once page cache is cold or weights aren't local, you fall back to slow paths. AI infra under attack, better telemetry. Attackers are already exploiting AI infrastructure like any other distributed system, sometimes with AI's help. Security researchers detail a campaign abusing Shadow Ray, CVE 2023-4822, in the Ray framework to compromise clusters and turn them into a self-propagating botnet. The operation reportedly used LLM-generated payloads to iterate faster, industrialized delivery via GitHub, GitLab, and stealth tactics to mimic legitimate GPU loads across clouds and regions. If you run Ray or similar frameworks, lock down dashboards and authentication. Assume your AI fabric is a target and harden it like one. On the Blue Team side, Windows will ship native Sysmon functionality starting next year for Windows 11 and Windows Server 2025, folding a staple of sysinternals telemetry directly into the OS. That means no more manual agent deployment, consistent patching via Windows Update, and the same detailed, configurable event capture socks rely on today. Rich visibility with less operational friction is precisely what AI-centric fleets need as they scale. RDNA 4 FP8 unlocks big gains. Community engineers just landed a major VLM uplift on AMD RDNA 4, GFX 201. Enabling and tuning native FP8 paths alongside Triton kernels and WMMA configs yields roughly 60% speedups on Qwen 330B in early tests, with reports that FP8 now matches or slightly surpasses the best INT8 GPQ setups, while improving coherence and static quantization. Critically, Adder now works on RDNA 4, unlocking proper flash attention, chunked prefill, and other fast paths that previously fell back to slower implementations. Others have reproduced the gains, and a Docker image with RDNA 4 optimized configs is planned pending stability checks. It's a pragmatic community fix, wiring up what AMD partially prepared and finishing it for real workloads. Under the hood, the contributor ran 73,000 WMA shapes via Aider to find fast configs that match realistic LLM matmul sizes. The improvements sit atop a VLLM nightly, where CUDA started providing actual speed on GFX 1201. The takeaway: with architecture-aware operator tuning and proper kernel paths, consumer-class GPUs can close more of the gap for inference, even for big models. Training-free 4K images, faster video VAEs. A new comfy UI node brings DIPE to flux-based diffusion transformers, pushing artifact-free 4K plus image generation without retraining and with negligible performance overhead. DIP dynamically adjusts positional encodings during sampling to match diffusion's frequency progression. low-frequency structure early, high-frequency detail late, curbing repeats and structural degradation beyond the model's native resolution. It's a simple, single-node patch for Flux architectures. It doesn't alter CLIP or the VAE and is not intended for UNet models. On the video side, the LightX2V team released a family of optimized autoencoders that trade quality, speed, and memory more gracefully. LightVa causal con 3D like official Wanma cuts memory roughly in half versus the official models and delivers 2-3 speedups while staying close on quality. LightTe Com2D hits minimal memory, 0.4 gigabytes, and extreme speed with quality near official. Benchmarks on H100s show stark differences. For a 5S 81 frame reconstruction, WAN 2.1 VAE encodes in 4.17 and decodes in 5.4x using 810 GB, while LightTe variants encode-decode in fractions of a second with tiny footprints. LightVAE sits neatly in the middle as the balanced choice. Agents need rails, not vibes. An emerging consensus from enterprise R&D: intelligence isn't enough. Reliability comes from structure. A widely shared analysis of recent AWS papers highlights 3 sober themes. You can't trust models to self-judge in high-stakes settings. Formal verification beats eloquence. Agents fail largely because we let them choose chaotic workflows, process design, improvisation. And in domains with strong inductive bias and real physics, foundation models don't automatically beat domain-optimized statistical baselines. Structure, raw scale. The refrain: the rails decide what that intelligence becomes. Practitioners running day-to-day agents see the same fault lines. Detailed reports underline non-portable context windows, incompatible KV cache formats across vendors, no consequence modeling, no internal notion of cost, risk, or rollback, amnesia between turns, no continuous self, and zero appreciation for human time. The root cause is simple. We're duct-taping a next token predictor into acting like a planner with memory and cost awareness. Without explicit tools, guardrails, and state, it happily deletes the wrong process because cleanup statistically correlates with kill. Teams experimenting with spec-driven development reach a similar conclusion. Use procedural orchestrators for planned priority state, and let LLMs handle creative generation within tight scopes, e.g., 1 file per task. Non-determinism makes end-to-end LLM orchestration drift-prone and architecturally inconsistent over time. Specs persist as living contracts. The process logic shouldn't. Agentic scaling with caveats. There's also chatter that GPT-5 Pro is a large agentic model, acting as a universal agentic gateway. Signals include no cache read price on OpenRouter for that tier, and usage declines that some interpret as pricing margin pressure. Users report mixed quality. One noted basic citation failures. The useful takeaway for the open community is architectural. Orchestrating diverse smaller models via routing could approximate frontier plus behavior if the blend is diverse and task-aware, though utilization and thrashing risks remain. A concrete counterpoint comes from open source. MiroThinker v1.0 8b30b 72b explicitly trains for tool-augmented long-horizon research with up to 600 tool calls and a 256K window. Benchmarks show strong scores on HLE Text, BrowseComp, BrowseComp-ZH, and Gaia Text 103, narrowing the gap with commercial systems. More interestingly, RL-tuned variants learn to perform significantly deeper, longer interaction trajectories than SFT-only models, gaining 8 to 10 points by exploring, verifying, and revising before concluding. A compelling demonstration of interactive scaling as a third dimension alongside model size and context length. Determinism, safety, and RAG hygiene. Researchers at Thinking Machines show that defeating non-determinism in LLM inference is possible but costly. The work targets subtle numeric sources, e.g., floating point summation order, that can flip outputs even at temperature 0. For reproducibility, especially in pipelines like RAG, this matters. But the trade-off is notable. Deterministic paths ran about 2x slower in discussion, which is fine for debugging and research, but harder to justify in production. Safety and faithfulness testing is getting more accessible for local stacks. Apollyon is a Python package that runs chain-of-thought-based faithfulness probes across any model available via Llama, and now Anthropic API, judging whether the model's reasoning aligns with instructions or goes off script. Projects like this make it easier to baseline safety behaviors across heterogeneous model fleets. RAG quality still lives and dies on chunking. A new CLI, RAG Chunk, lets teams test fixed size, sliding window, and paragraph-based strategies with recall-based evaluation, including token-accurate chunking via tick-token. In sample runs, paragraph-based splits achieved the highest recall by preserving semantic boundaries, a reminder that simple structure often outperforms brute force chunking at equal budgets. Big multilingual data, fast domain adaptation. The HPLT 3.0 release drops a colossal 30 trillion token multilingual dataset for LLMs and MT, roughly double the reported Llama 3 scale, 15T. As always, the caveat is quality and cutoff. Size helps only if the extra tokens add signal, not just recency noise. But for multilingual pre-training and transfer, the sheer breadth matters. On adaptation, a new ArXiv paper proposes compress to impress, using a single gradient step on just 100 samples to score which singular value components of weight matrices to shrink, enabling fast, training-free rank reduction without lasers' exhaustive sweeps. The method computes gradients of singular values on the small calibration set to decide what to prune, clusters rows to broaden factorization options, and evaluates candidates on the same tiny set, yielding major speedups with competitive accuracy. For on-device or rapid domain pivots, this kind of surgical compression is especially attractive. There's also active community discussion about more surgical approaches to pruning and ablations. The shared direction is clear. Smarter, targeted reductions instead of blunt cuts, preserving the subspaces that matter for the task. Local stacks, frontends, and engines. OpenWebUI Lite is a dependency-free Rust rewrite of the popular UI with a Tory desktop build and a minimal server that avoids Docker and heavy services. Early testers asked for Docker images, data migration scripts, and MCP server support. Here, MCP is Model Context Protocol. While some hit macOS quarantine warnings and local Alama connection edge cases, typical bumps for a fresh rewrite, but the direction is promising for low-resource boxes. If you do run OpenWebUI locally, Firefox's AI sidebar can be pointed at it. Flip a few about config flags, enable the chatbot, allow localhost, then set the provider to your OpenWebUI URL. The result is a native-feeling sidebar flow that stays on device. On the language runtime front, Brimstone is a new JavaScript engine written in Rust with 97% ECMAScript test 262 coverage, a compacting GC, a bytecode VM inspired by V8's Ignition, and support for ES 2024 plus the latest Phase 4 proposals, e.g. float 16 array, including precise fixes like correct rounding for number.prototype.toFixed. It's not production ready, but it's advancing quickly with robust test harnesses. Finally, the Aider ecosystem is seeing community realignment. Aider CE, the long-running community fork, was made official to accelerate merging of outstanding PRs and triage of issues after frustrations with stalled governance. Expect rapid iteration and some bugs as the fork organizes under new stewardship. AI at the wound's edge. Researchers at UC Santa Cruz prototyped an AI-enabled smart bandage, a heal, that slots into commercial colostomy bandages, shooting images every 2 hours and using a model to recommend interventions, either electrical stimulation to reduce inflammation or local delivery of fluoxetine to promote tissue growth. In tests, it improved skin coverage rates versus controls. It's early stage, and even commenters flagged the unusual use of Prozac in wound care, so treat it as a proof of concept, but it points toward cheaper, continuous monitoring and adaptive therapy for chronic wounds.